MicroRNAs are short, single-stranded, non-coding RNA molecules that regulate the activity of messenger RNA. A microRNA molecule is typically 20 to 24 bases long, averaging on 22 bases, much too short to encompass standard PCR primers, which tend to be roughly of the same length. Our two-tailed primer is coiled into a hairpin structure, with a generic structure in the middle. It has two targeting regions, known as hemiprobes, which are complementary to the microRNA. Taken by itself, one of these hemiprobes is too short to bind to the microRNA. However, when two form part of the same molecule and one of them does happen to bind, the local concentration of the other is so high that it binds too, thus forming a stable complex. In the case of a mismatch in either of the hemiprobes, interaction is weakened. Compared to a standard primer RNA interaction, the two-site interaction dramatically increases specificity in the RT step. While a mismatch perturbs only 1 out of 20 bases with standard PCR, the two hemiprobes leads to a mismatch of approximately 1 out of 5 bases. When a standard complex is formed, a reverse transcriptase binds to the 3' end of the two-tailed primer and extends it, thereby displacing the 5' hemiprobe. This extended two-tailed primer, which harbors complementary sequences to the target in both 5' and 3' ends, is what forms the cDNA. The cDNA is then amplified by PCR, using standard forward and reverse primers. Both PCR primers contain sequences that are complementary to the original microRNA, adding specificity to the PCR amplification as well.